So we've got 4 different applications here. These are a little bit more complicated than the previous problems. So let's read our problem. It says, Lyudmila wants to buy a rug for a room that is 20 feet long by 15 feet wide. And so if you read it, it looks like she wants to buy a rug, but it ends with room. So the room is 20 feet by 15. Put a little feet mark up there. All right. She wants to leave an even strip of flooring uncovered around the edges of the room. So this is our rug here. This part right here, this way as well. So that is our rug. It says how wide must, oh, there's our variable. So x is the width of the strip. It's not always a question, but it's where you want to start because that is an unknown. And it says we also have an area that is 234 feet squared. So if we have an even strip, this is what we call as x, that even strip. And we might as well just finish each part like this, just like we did that box problem. But that's what you want to do for each one. And what that does is it now gives us the little x's that we need to solve this problem. Now, when you put area is a very vague thing. So you want to say what it is. This is area of the rug. Well, that's what she said. It needs to be the rug. And so we need to know what are the dimensions basically of this rug. That's what she's asking for. If we know the strip, we know the dimensions. So anytime you see this situation going on, you know that this has to be 20, take away 2 x's. And this over here would have to be 15, take away 2 x's. Because that's 20, and we're going to have a strip here that's x and a strip here that's x. So these have to add up to 20. And these have to add up to 15. So it's basically 15, take away 2 x's. It's 15, take away this and this. You can see that these are being removed from here, and we get what we need. Okay, so if that's our 2 dimensions, we now know the area. Remember, area of a rectangle is length times width. So we would have 20 minus 2x and 15 minus 2x. And all we have to do now is make our function. And you don't have to multiply these out. We are using a calculator. If you do, that's great. And you can use quadratic formula or factoring to solve these. But we've got a lot of applications, and setting it up is the most important part right now. So this is 234 equals 20 minus 2x and 15 minus 2x, because that's our area. And so this is our quadratic. And so by solving this, it will tell us the x we need that will give every single condition that she has here. So let's plug this into Desmos and see what it gives us. Okay, so I have my 20 minus 2x, and you can put a y equals here as well if you want, but we're just setting the left side equal to y and the right side equal to y to find out when these 2 y's are equal. And so we need to scroll over. There's our quadratic, our parabola, and we need to scroll up to 234. So I'm going to zoom in a little. And then there it is. That's our point of intersection up there. So again, if we click on these 2, we get that one and that one. So when x is 1, we will have 234. And when x is 16.5, we will also have an area of 234. So 1 and 16.5. Let's go back and write our answer. So when our x is equal to 1 and our x is equal to 16.5. Now one of these does not make sense. So think about it. You have an x here. If I were to take 16.5 away from this, I would cut the entire side off because we only have a 15 foot wide. So can you have a strip that's 16? No. So it's 1 foot. If she cuts 1 foot, she has 1 foot gap around each one. She will have her rug. So what dimensions are a rug? Let's just make this a little extra. So if you take that x and plug it in, this would be 20 minus 2 times 1, and 15 minus 2 times 1. And so that would give us 13 and 18. So she needs to go out and buy an 18 by 13 rug, and it would give her a 1 foot gap around here. 1 foot this way, everything will work perfect. Okay, so we're going to try the next one. So on this one, an architect is designing these little triangular houses, and he's got a door put in here. They've got to be 4 meters high, 5 meters wide, and so our door is going to have some width and some height to it. And so we're trying to fit some door in here that has to match code. You can't have these doors being, you know, a meter high that's like 3 feet. How are you going to get in? You're going to have to slide into the house. It's not going to work well. So we need to make a formula for this door. So they express the area W of the door as a function of the width W. So we need to make some formula for this door. So we know the area of a door would be width times height, because that is how it's labeled. That's the width and that's the height. Now we need this to be a function of the width. So A equals W times something that has W. Well, anytime you see a triangle, you want to locate that triangle. These are isosceles, like this. And you want to find a similar triangle in that same shape. So it wouldn't be this one. That doesn't look right. So it has to be this top one right here. And you can see it involves W, which is good. And then you take those two triangles and you redraw them off to the side. If they are similar, then their dimensions are proportional. That's the nice thing about similar triangles. So we know this big one is 5 and 4. And so the little one will be W and 4 minus H. So where do I get that from? Well, the W is pretty clear. It's the width of the door. But this right here is not as clear. So why don't we do that as a yellow highlight right there? And so where does it come from? Well, if you look, this whole height, the entire way, all the way up, is 4. And this right here is H. So if we take our 4 and subtract H, we get W. Our H is here. And this is the one we want, the yellow. And so you can see that this would be 4 take away H. So 4 take away the H gives us 4 minus H. And we get these two triangles. Once you have that, that is the hardest part. Everything else from here is coasting. So we know our height to our width of the big triangle is equal to the height over the width of the little triangle. And if we cross multiply, we get this. And the letter we are trying to replace is H. So if we solve this for H, we can plug in for H. So you always solve for the letter you want to replace. Solve for letter to replace. So this would be 4W minus 20 equals negative 5H. Divide by negative 5. And we get negative 4/5 W plus 4 equals H. And so that is what we plug in, negative 4/5 W plus 4. And then that is our quadratic. Let's simplify this. This is negative 4/5 W squared plus 4W. So we know it looks like this because it has a negative in the front. So let's see how we're going to use this now. So that is all the areas. So let's plug this into Desmos and see what it gives us. So if you remember, X is our width. I've already plugged it all in now. Here's our equation. X is our width, and this is the area. So based on the width of the door, so if you had the door with no width, obviously the area would be 0. But as you make the door wider, right, and so that right there is a meter. If our door was 1 meter wide, it would have an area of 3.2 square meters. And so looking at this, we already know that that right there would be our highest. So if we make the door 2.5 meters wide, it would give us the biggest area, which is 5 meters squared. That is the biggest area we can get. So if you go wider than that, the door's area gets smaller, because as you go wider, right? As you go wider, the height gets smaller. So if you look at our picture here, as you make the door wider, if we made it wider, right? See how low it is? So there's a width in here that gives us the max area. And so let's find out what they want us to do. It doesn't care about max. It's saying here that a provisions of the building code requires that doorways must have an area of at least 4.2 square meters. So the area of the door must be 4.2 square meters. So what we're getting is this. And so we can solve this using quadratic formula, but like I said, that's painful and we don't need to. So if we go to our calculator and we put in 4.2 and hit enter, with a y in there, of course, y equals, we have now made two equations. We made one for the right side and one for the left side. And by putting y equals 4.2, it tells us the intersection point. So if we make the door 1.5 meters wide or 3.5 meters wide, we will have our area. So our W equals 1.5 meters or 3.5 meters. And then just to give work for our answer, we know it's 1.5 and 3.5. So there's your solution. Right there. Just plug it into Desmos. You just have to make an equation, make a left side, and solve it. And this allows us to give really complicated problems, not these generic simple ones that we're given. Okay, let's try another one. So a gardener has a 25 by 50 foot rectangular plot of land. She wants to build a brick walkway of uniform width, sound familiar, on the border of the plot. So the gardener has a 25 by 30 foot rectangular plot of land. She wants a brick walkway around the width. The gardener wants to leave 500 square feet of ground left for planting. How wide should the walkway be? So again, it's the same problem. We have, this is 30, this is 25, and you have an even walkway around the outside. See, they're the same problems over and over again. And so this is ground in here. This is our dirt. Do red. That's our dirt for plants. And we're going to put some little trees in here, right? And some flowers. It's a blue flower. Blue tree flower. Okay, so she wants to build a brick walkway. And the gardener needs to have at least 500 square feet of ground left for planting. So that's an area. When you see square feet, they're saying area. And our area is length times width. So this is the same problem we did before. 500 equals, and then 30 minus 2x, 25 minus 2x. And so if we plug the left side in as y equals and the right side in as y equals and the left side in as y equals into Desmos or your graphing calculator, it'll tell us our answer. And again, we just scroll out and then scroll up. We got to get up to 500, and there's our line. Clicking on anything, there we go. So we get, be careful not to use that one. Remember, that's 0, 500. So 2.5 and 25. So obviously one of them makes absolutely no sense. So our x here is 2.5 feet, and the other one is 25 feet. And obviously you can't do 25 feet. If you did 25 feet as a walkway, well, you've only got a 25 feet piece of land, so it'd just be a giant paved area. So it's 2.5 feet. So what's the dimensions of the side and side? So of the dirt, how much room do you have? So if we put the 2.5 here, and then the 25 minus 2 times 2.5 here, it should give us our dimensions. So that's just 30 minus 5, which is 25. And 25 minus 5, which is 20. And putting that together, look, there's 500. So she's going to do a 25 by 20 foot lot inside with a 2.5 foot wide pathway. It's kind of narrow, but that'll give us her stuff that she wants. All right, so same problem as the dirt. So this one's going to be similar to the other one, right? This one. Okay, so let's try this one now. So it says a play area is to be built as described in the picture. So we have this picture. It's got a lot of land that's 300 by 500. And we're going to put this rectangle in it. See, very similar. The available lot shape is a right triangle with legs of length 300 by 500. So remember, the legs of a triangle are the ones that are not hypotenuses. What dimensions of a right triangle? What dimensions are the two possibilities? Should the use of the rectangle play area to have an area of 30,000 square feet? So we know an area is length times width. It's already labeled, and that has to be 30,000 square feet. Okay, so we need some sort of function here in terms of W, which means we are replacing L. So remember, we talked about this before. We want to draw our triangles. So this one right here is our big triangle. And the reason we're picking it is because it has numbers on it. It's got dimensions. And so you need to find a similar one. And I've already labeled this one, so that's the one we're using. You could also use this one. They would work as well. That is also similar. The way you can tell is because we have a parallel side and a parallel side. That this side is parallel to this one. This side is parallel to this one. So on. The legs are parallel. See? Okay, but we're going to use this one. So that one was blue. That's a little one. And we call that 500 minus L. Same rules as before. This is 500. Take away L, so that would be 500 minus L. And that one is W. And then we plug it in. So 300 is to 500, as W is to 500 minus L. And then now we can cross multiply. So this would be 150000. So 300 times 500 minus 300 L equals 500 W. And again, we're solving for L because we want to replace L. So minus 300L equals 500W minus 150,000, 4 zeros. And then we divide by negative 300. And you got to pay attention to the zeros here. So this would be negative 5/3 W plus 500. So 2 zeros are canceled, leaving us with 2 zeros there. So 15 divided by 3 is 5. All right, so now we can plug that in. And then this equals negative 5/3 W squared plus 500 W. And then now we're going to be using this a little differently. So we're going to be plugging this into our TI-84 to find the solution, not just Desmos. So in order to use a TI, it's not as easy as scroll around and go. You do have to move stuff. So to make it much more functional, what we're going to use is the domain of W. And it's not too hard to calculate. So our W here is the height. It's this thing right there, right? So our W is going to go up as we make this box larger all the way to there. So we can start at 0, but it's going to end at 300. So just by looking at the width compared to that width, it tells you what it is. So we could have a minimum of 0 or a maximum of 300. Don't put brackets here because you have to go bigger than 0 or less than 300. So now if we plug this in our calculator with what it wants us to have is 30,000 square feet to be equal to our area. With this domain, it'll give us a nice focused location. We don't have to scroll around or look for anything. Watch, it'll be very nice. So we make Y1 our 30,000. Y2 is the area formula. We set our window between 0 and 300. And by doing this, it gives us a nice focus. We know our width can't go less than 0. It can't go more than 300. So now if you hit zoom 0, it will fit it to that realistic domain. So there is our 30,000 line, and here comes all of our areas. So as our width goes along here, right, our width is increasing from 0 to 300. So as our width increases, I can even hit trace and follow it. Scroll down to the red. Let's put 0. So right there it's 0, right? And you can see as the width increases, our width now is 27. That gives us our area, and so our area is increasing. As our width increases, so does our area until there. So at that intersection point, it is now above 30,000, and that's what we're looking for. So these widths here give us an area that is more than 30,000. So if I can find that point of intersection and that point of intersection, you can see our width will be more than 30,000. As I continue to here, and now our width is less than 30,000. So we go second calc, and then we use the intersect function, inner, and as long as our guess is near that one, it will give us that one. So that one is 217.18, 217.08, sorry, not 1808. And now let's find the other one. So second calc, intersect, and again, you select the function. So the first one is the blue line with the red. You see how I just changed. And now we need to guess. So if we select it, it's going to give us the same one. We need to be over here. So you just need to guess close to it. So you could even guess 0 because we know that's our min. And look what it'll give us, that one. So 82.92. I'm writing them down. All right, so now if we go back, we can draw that picture. I know the colors are backwards, but we know that we're going to be at 217.08 and 82.92. And that's this right here is 30,000. And so these are above 30,000. That's what we want. We want this region here. So as long as what dimensions, all we're going to do is list the width on this, not have to worry about the length, because the length will go along with the width. We have our formula over here. So if you plug in the widths, it would give us the lengths. So we're going to just focus on our width. Our width needs to be between 82.92 and 217.08. And then you look and see, does it say more than? But it says of this or more, which means we use the inequality. If it had just said of an area of 30,000 square or more than 30,000, then we would just use that. So our width will also be between 82.92 comma 217.08. So you can list it in interval notation, or you can list it this way. But if you were to plug that in, it would give us our length, and plug that in, and it would give us our length. Okay, there you go.